This video is on springs in series. Those two springs are in series, one right after the other. In the World Series, you play one game, and then after that, you play another game, and then you play another game after that. So when we say series in physics, we mean one right after the other. If you're listening to a lecture series, you do one lecture, then you do one after that, and you do another one. Series means one right after the other. That's what we have here. When we apply our force here at the end, we're going to pull on this. What's going to happen with regard to the forces in each of these springs and their displacements and so forth? I think when we pull with an applied force, isn't that applied force going to be the same throughout this? Which means I think down here, F1 is going to equal F2 is going to equal F applied. Spring 1 is going to stretch a bit, and so is spring 2. And so the total amount of stretch that we're going to measure, I think, is going to be that one right there. We're going to use those ideas then right here. I've recopied our correct answers from the previous page right there. One of our part H answers should have a positive symbol in it, which is that one right there. We're going to use Hooke's law. We're going to transform that answer's equation from the one type of variable that it already has, which is x, into the other two types that are in Hooke's law. Hooke's law, you recall, is that the force is equal to k times x. If we want to transform equation 1 in terms of the other variables, isn't x equal to f divided by k? So now let's rewrite this first equation with that in mind. The displacement x1 can be written as f1 over k1 plus, now we've got f2 over k2, and that's going to equal the applied force, which we're pulling with, divided by x total. Sorry, k effective. K effective. The effective spring constant of the system. The other part H answer has all equal signs. Use this idea to simplify part I. F1 equals F2 equals F applied. I might just call that F. So that means that I can take this answer here and I can say, well, that's F, and that's F, and that's F. All the F's are the same. And now I divide through by F. And doesn't that leave us with 1 over K1 plus 1 over K2 is equal to 1 over K effective? When we have springs in series, we have to use what I call the 1 over rule in order to find the effective spring constant. And of course, if we had 3 springs, we would use the same pattern. I'll write the Kf on the left this time. 1 over K1 plus 1 over K2 plus 1 over K3. You just do that for however many springs that you have, as long as those springs are in series with each other.